Now we're going to look at how do we accomplish doing definite integrals, ones where we have a and b in the bounds of integration, and alongside with substitution. Now there are different ways of approaching this one. My suggestion is to, first off, just consider the indefinite integral. By doing so, we're just going to be finding the antiderivative and not worrying about plugging in any numbers. Once we figure the indefinite integral, then we can evaluate using the bounds of integration, just to try to make it as simple as we possibly can here. So we'll have something like the integral between 0 and 4 of the square root of 2x plus 1 dx. So let's just take a look first off at just the integral of the square root of 2x plus 1 dx on its own. Now this is a situation for substitution that we make for the inside of the square root. We let u be equal to 2x plus 1, then du would equal to 2 dx. And we need to divide over the 2, so 1/2 du is equal to dx. So our integral would change into the integral of the square root of u, 1/2 du. Okay, and so this is equal to the integral of u to the 1/2. We'll put the 1/2 in front. So 1/2 the integral of u to the 1/2 du. That's equal to 1/2 times u to the 3 over 2 divided by 3 over 2 plus a constant c. So this would equal to 1/3 u to the 3 over 2 plus a constant c. And plugging back in for u would give us 2x plus 1, here raised to the 3/2 power, plus a constant c. So that's the indefinite integral, that's the antiderivative for this function. So what we're going to do next then is actually calculate the indefinite integral from 0 to 4 of the square root 2x plus 1 dx. And again, by the fundamental theorem of calculus, that means we plug in for 4 and we plug in with 0. And our antiderivative we just figured out in the last step by doing the indefinite integral. So this is going to look like 1/3 times 2 times 4 plus 1 to the 3/2 power. That's the first part, minus 1/3 2 times 0 plus 1 raised to the 3/2 power. And again, I'm ignoring the constant c since we're just dealing with plugging the numbers in. So this is going to turn into 1/3 times 9 to the 3/2 power minus 1/3 times 1 to the 3/2 power. So this is going to be 27 over 3 divided by 1/3, which is going to equal 26 divided by 3. Now let's look at this one that says integral from 1 to 2 of dx over 3 minus 5x all squared. So like we've done before, we're going to start out with just the regular integral, the indefinite integral. We're not going to worry about plugging in numbers until we figure out the antiderivative. And then we can plug the numbers in to figure out the definite integral. Now this is a candidate for taking substitution, integration by substitution. We're going to let u be the inside of those parentheses, so 3 minus 5x. Then du is going to equal to negative 5 dx. So when we divide over the negative 5 here, we'll figure out that negative 1/5 du is equal to dx. So making the substitution here, our integral is going to change into 1 over u squared times negative 1/5 du. I'm going to move the negative 1/5 to the front. Negative 1/5 u to the negative 2 du. So that would turn into negative 1/5 times u to the negative 1 divided by negative 1 plus a constant c. So that's going to be equal to 1 over 5u plus a constant c. But we need to plug back in for u, so that'd be 5 times 3 minus 5x plus a constant c. We could even take that a step further and make that 1 over 15 minus 25x plus a constant c. So that's our antiderivative, most general antiderivative, because we put the plus a constant c. The next thing to do is consider the definite integral from 1 to 2. And now we can calculate this using the antiderivative we just figured out. Fundamental theorem of calculus says plug in the 2, plug in the 1 in the antiderivative, subtract those. So for us that would look like 1 divided by 15 minus 25 times 2 minus 1 over 15 minus 25 times 1. Not again including the constant c because of the no need for it when plugging in the numbers. This will equal to 1 over negative 35 minus 1 divided by negative 10. Or in other words, negative 1 over 35 plus 1 over 10. Now if we're doing this by hand, we'll have to get a common denominator. This would be negative 10 over 350 plus 35 over 350, which would give us 25 over 350. That would simplify down to be 1 over 14. Okay, here we're going to take the integral from 0 to 4 of x over the square root of 1 plus 2x dx. So first things first, let's consider just the regular indefinite integral. And this is another candidate for u substitution, where we'll make the substitution of u to be the inside of the square root. So step 1, let u be equal to 1 plus 2x. Then du is going to be equal to 2x, or just 2 dx. We'll still need to divide over the 2, so that 1/2 du is equal to dx. Now what we're going to have to do, we do have now a substitution for dx, that's 1/2 du. But left is x. We don't have anything there directly to substitute in for it. So what I'm going to do is somehow solve for x. And I can do that by taking u equals 1 minus or 1 plus 2x. If I solve for x, 2x would be equal to u minus 1, and so x would be equal to u minus 1 divided by 2. So that's what I need to substitute in here for x. U minus 1 divided by 2. Okay, this is kind of a little bit weird. Let me take this integral and rewrite it one more time before making the substitution. Think of it as 1 over the square root 1 plus 2x times x times dx. And now each part is going to have a substitution done for it. This will turn into 1 over the square root of u. X, we're going to put u minus 1 divided by 2. And for dx, we're going to put 1/2 du. Okay, let's change this up a little bit. We're going to bring out a 1/4 times the integral u to the negative 1/2 times u minus 1 du. Distributing u to the negative 1/2 here would give us 1/4 times the integral u to the 1/2 minus u to the negative 1/2 du. Okay, we can take the antiderivative here, so that would be u to the 3/2 power divided by 3 over 2 minus u to the 1/2 power divided by 1/2 plus a constant c. So simplifying this down, we're going to get 1/4 times 2/3 u to the 3 over 2 minus 2 u to the 1/2 plus a constant c. Multiplying through by 1/4 would give us 1/6 u to the 3 over 2 minus 1/2 u to the 1/2 power plus a constant c. Now the last step is to go ahead and substitute back in for u. So that's going to be 1 plus 2x raised to the 3/2 power, and then 1 plus 2x raised to the 1/2 power. Okay, so that's our antiderivative for this one. The next thing to do is to take our integral. We're using the integral between 0 and 4 of x over the square root of 1 plus 2x dx. And so we just need to plug in the value of 4 minus plugging in the value of 0 into our antiderivative. So down here I'm going to write down, plugging in the numbers to the antiderivative, 1/6 times 1 plus 2 times 4 to the 3/2 power minus 1/2 times 1 plus 2 times 4 raised to the 1/2 power. So that's the first part. And then we plug in the 0. 1/6 times 1 plus 2 times 0 raised to the 3/2 power minus 1/2 times 1 plus 2 times 0 raised to the 1/2 power. Okay, and so what we're going to get here is looking like 9 to the 3/2 power divided by 6 minus 9 to the 1/2 power divided by 2 minus 1 to the 3/2 power divided by 6 minus 1 to the 3/2 power divided by 2. So that's looking like 27 divided by 6 minus 3 divided by 2 minus 1 divided by 6 plus 1 divided by 2. That looks like 26 divided by 6 minus 1. So that would be 26 divided by 6 minus 6 over 6, or 20 over 6, which would reduce to 10 over 3.